Poynting vector of the electromagnetic wave. It is defined as the rate of flow of energy per unit area perpendicular to the wave propagation. Wave propagation. So it means that if suppose this is now wave and here we have this is now area or surface, and this is the wave, this is the flow of energy, then this is called the Poynting vector P. Unit joule per meter square into second or watt per meter square. So this is the flow of the power per unit area. Poynting vector represents flow of power per unit area. Perpendicular to wave propagation. Wave propagation. The name Poynting has been given after its discoverer John Henry Poynting. And it is denoted by P. So now it is the cross product of E and H. So what we have that this P is equal to E cross H. It means that this P is P is perpendicular to E and P is perpendicular to H, both. Now we can have that this P is equal to E cross B upon mu naught. This is now also as this H is equal to B upon mu naught. We know this relation. Mu naught the magnetic permeability of the free space. So it is perpendicular to both E and H. So this means that this P is along the direction of propagation of the wave. This is what that we have written here, that it represents the flow of power per unit area perpendicular to the wave propagation. So it is always along the propagation of the wave. Thus P is always along the wave propagation. Wave propagation. So now we can have that, if suppose we are having this is now Z direction, this is now Y direction, then here this is now B, here now this is E, and here we have this B. Then we can have like this, and this B is in this way. So this is for E and it is for B. This is now wave. So this is now direction of P. It is now P. So P is along the propagation of the wave. So it is perpendicular to both E and B or E and H. Now this P is equal to E cross H. So now we can have this E H sin theta into n cap. This is now vector P, where theta the angle between this E and H. So now what we have, that this is suppose E and this is vector E. So this is now E cross H. The angle between them, this is so much. So this will represent the n cap direction of the wave propagation. So now from here, that if theta equal to 0 degree, then P is equal to 0. It means that no power flow when the electric vector and the magnetic vector are parallel to each other. And if theta equal to 90 degree, then this P is equal to E H into n cap. This is the maximum power. Maximum power. So maximum power takes place when E and H both are mutually perpendicular. Now this P is equal to 1 upon mu naught into E cross B. So now we can write that the velocity of light, light C equal to 1 upon square root of mu naught epsilon naught. So this is your epsilon naught C square equal to 1 upon mu naught. Therefore, this P is equal to epsilon naught C square into E cross B. But this B C equal to E upon B. So now we can have that this B equal to E upon C. So now we can write that this P, so P is equal to epsilon naught C square into E cross E upon C. Now here E cross E is not equal to 0 because this has been put in place of B. So this P is equal to epsilon naught C square into E square upon C. So this P equal to epsilon naught E square into C. So P equal to U into C, where U equal to epsilon naught E square, the total energy density, the total energy density of wave. So thus the product of the total energy density to the velocity of light is equal to the this Poynting vector. Thus product of U and C is equal to the Poynting vector. Poynting vector. Though this Poynting vector represents the flow of the power per unit area, so this is not a vector quantity, but even we represent it by a vector because the energy flow is related with the direction of the wave propagation, and wave propagation will take place either the x direction or y direction or z direction. So according to that we have taken the word vector here. So this Poynting vector is nothing but the power flow per unit area perpendicular to the wave propagation, or this is always in the direction of the wave propagation. So these are the different formula, and this is now relation between this E, H, E and B, and that gives you the Poynting vector, and that we are having this U into C, the total energy density of the EM wave multiplied by the speed of the light, that will give you this Poynting vector. So this is about the Poynting vector. So thank you. Bye.